Hi everyone, welcome to this session on building command line tools in Go. My name is Ayo, and I'm a technical content manager at Dash Zero, where we focus on open telemetry native observability. And I'm also a Google developer expert in the web category for the last 2 years or so. What I'm going to be talking about here is drawing from my experience building command line tools. Command line tools precede those tools. Those tools are even more newer than some of the old Unix tools that we've had for a long time. And in the early days of computing, command line tools was pretty much the only way you had to interface with a computer, right? You didn't have the advanced UI that we have today. But why are we talking about command line tools when we now have these new interfaces? We have web UIs, we have mobile UIs, we have desktop UIs. Why do command line tools still matter? And it's because they still remain unmatched in so many different ways. They can, they are first class citizens for automation. So if you want to automate something, the best way to do it is with a command line tool. You can't easily do it with a GUI, right? And also, they are composable by design. So you can combine different command line tools together and get, different results based on the combination. And this is by design because they are designed to be composable. And also, they are very lightweight, they are portable. You don't need so much, you don't need to install so many things to get them running. Usually, you only need a single binary, at least in case of Go and some other languages. And their text-based nature makes them very transparent. So there's no UI, there's no complicated UI or anything like that. So they're very transparent and inspectable. So let's talk about why Go is actually a perfect fit for the command line tools. Because you can actually build CLIs in almost any language. And one of the reasons why Go is the perfect fit is because, first of all, it compiles really fast, and it also compiles to a single binary. And that is one of the biggest advantages that Go has over other languages like, say, Python or Node.js, for example, because you don't need to have the runtime installed. You don't even need to have any specific dependencies installed. You can just distribute the binary and your users will be able to run it. Then secondly, it's high performance, low overhead, so it doesn't use much system resources. So, it can run anywhere. And then also the standard library is very featured, right? You don't need to reach out for, packages just to do basic stuff like reading files or, making HTTP requests. You can do everything from standard library without installing anything. And then even if you need to reach out for packages, there's actually a very large thriving ecosystem of command line packages specifically made for building command line tools. So that's one of the reasons. Those are some of the reasons why Go is actually very, very good for building command line tools. And these are just some examples of some command line tools that already exist and are written in Go. We have Docker, Kubernetes that I already mentioned. We have Terraform, GitHub CLI, Hugo, Lazy Docker, and so many of others as well. So the ecosystem is large. These are just a few that I, thought to highlight, but we have a large ecosystem of command line tools written in Go, possibly only superseded by maybe Rust, for example. So when we talk about command line tools, you need to know that there are really two types of command line tools. We have the classic CLI, so that's the command line interface. And this is the one we are probably all familiar with, where you give it arguments, you type a command, give it arguments, it prints a task, it runs its task, and then it prints some outputs and exits, and then you have to prompt it again. And I give an example here of Git. So this is the Git interface, Git status. It outlines that workflow. But there's a different kind of command line interface, and that is the terminal user interface, or TUI for short. So this kind of command line interface, it's like a GUI, but it runs in the terminal. So it's a full screen application, and it's best meant for something that's very interactive. So this example is HTOP, although HTOP is not written in Go, but it just exemplifies what a TUI looks like, and it's one of the most popular ones out there. So it's a process manager for Linux where you can see what your processes are doing and check their RAM, their memory consumption, the CPU consumption, and maybe queue them, for example. So now that we have an overview of command line tools and why they are still useful, let's go to part two where we'll be talking about how you can actually build a command line tool in Go. So I have a minimal example here of what basically this is like a hello world for building a command line tool, right? And all it does is it takes it defines a flag called name and it gives it a default value of world, and it also provides some help text, and then you have to call flag.parse to wait for the user to input, and then you print whatever is imputed or the default value. And this is what you get. So if you run main.go, you get hello world. But if you pass an argument to the name flag, then you get whatever you passed in. So that's how easy it is to start building command line tools, even without installing anything. You can see everything we did. We used the standard library for that to read arguments and print results. You don't need anything to get started. But as we all know, usually when things get complex, you usually have to reach for a framework, and Go has you covered there as well. We have frameworks for building command line, building CLIs, and also frameworks for building TOS, which I will show you shortly. But what a framework does is basically gives you structure, right? Allows you to structure all your commands, all your subcommands, and it does a lot of the low-level details for you. So that Flag package I show you, there's a lot of things you have to do to make it work nicely. But with a framework, you can just, you don't have to do all that anymore. You just use the framework and define it as it allows you to. So let's look at some of the great options we have for building command line tools in Go. The most popular one is Cobra, and it has, I think, over 10,000 stars on GitHub, and it powers tools like Kubernetes and also the GitHub CLI and so many others. So it's the one most people reach for when they are building command line tools. There's also your fave/CLI, which is also very popular, but not as popular as Cobra. But it's actually the one I tend to gravitate towards because of how simple it is. I just think it's a bit simpler. So that's what I personally use. And then there are others like Kong and Go Flags. And we also have TUI frameworks, that's Terminal User Interface frameworks. And the most popular one is Bubble Tea. It's kind of newish. I don't think it's up to 3 years old, but it's really took the Go ecosystem by storm because of what it offered. It was very, very good. So it's now really popular. And it's the one I would generally recommend if you want to build anything like a terminal user interface. But it comes with like some concepts, like it has this model update architecture that feels a little bit like React. So if you're looking for maybe something a bit simpler, then you can try out TView. That's another option that has some ready-made widgets that you can just use. All right, so this is an example of a TUI built with Bubble Tea. And this is a Hacker News reader. So you can basically, everybody knows Hacker News, right? So this is just a Hacker News reader in the terminal, and it's built with Bubble Tea, right, as I mentioned. So that's just an example for you to check out later on. So yeah, this is an example of Cobra being used to bootstrap a command line tool. So it's the same thing we had earlier, except that I'm using Cobra now to define the name of the command, which is going to be greet in this case, and a short help text, and then also the function that will be run when this command is executed. And then we have the name flag as well with the same name argument, the name flag, and then you have the short end, flag, and then you have world, which is the default value. And then you get the same results when you run it, get hello world, but when you pass a name, you get whatever you pass in. But one thing that a framework gives you is that it gives you an easy way, it automates something. So for example, it gives you this help flag automatically, right? So I didn't define a help flag, but it already did that for me. And you can see that it has what we put in the previous slide. So we have the short description, and that's where you get and you also get the flags automatically. So that's just a small piece of what frameworks do for you. If you are using the standard library, you have to do all this by yourself and the formatting and everything. So that's just that. So these are just some other useful packages for building CLIs. So we have the Charm suite. Now the Charm is the developer of Bubble Tea, and they have other packages as well, like lip gloss, and so many others that are for styling terminal user interfaces. So you can go to charm.sh to see all of them, and they're really well made and high quality. You also have Peter, which is one of the tools I use regularly. It just makes makes it easy to beautify CLI output. So if you want to render a table or you want to colorize some text, then you can reach for Peter. Then there's Viper, which is a complete configuration solution, and it helps you if you need a configuration file, then you can reach for Viper. So it helps you configure your command line through different means. And there are so many others, but these are just a few I thought to highlight that you can always reach for. So let's talk a little bit about some things you might need to take note of when you're building your command line tool. And that is writing platform-specific code. I think most of us, when we are maybe building servers, we're just deploying to Linux or something. So you don't need to care about how the software behaves on other platforms. But when you're writing a command line tool and you're distributing it for people who are using Linux, they're using macOS, they're using Windows, you need to care about how things behave on each platform, right? You need to write tests specific to the platform, and you need to write platform specific code sometimes, not all the time. It depends on what your command line tool is doing, but this is something I've had to do a few times. So I thought it would be important to highlight it here. So, and how you do that is by placing a special comment at the top of the file, and it's called a build tag, right? And these are some examples. You have go build Windows, which means everything in that file targets Windows alone. And then you have go build, and then if you put an exclamation mark or a band sign symbol beside the OS name, then it targets any OS, but that's OS. So you have here it targets any OS. So apart from Windows, so if it's going to run on Linux, Mac OS, or any other OS that's not Windows. And then you have downwind. So downwind targets Mac OS only. And then you have Linux, right? So that's pretty straightforward. So these are just some examples of the tags. There are a lot of others. You can even target specific architectures. If you want to write software that runs only on ARM Macs versus x86 Macs, you can do that as well. So many other examples. This is an example, let me just call it a real world example. This is my personal project where I had to write code that I have to write a function that checks if the file is hidden, right? I just want to check if the file is hidden so that I can skip it by default. And you can see the Windows is a bit more complicated. But you can see that due to the build tag, we've targeted Windows only. So when I'm building my code and I specify Windows as the target, it's only going to include this file. It's going to ignore this one. If I'm building for Linux or macOS, it's going to include this and ignore that. So that's how it works. Now let's talk a little bit about logging and output discipline, because it's actually very important for how command line tools work. So generally we have two streams. We have the standard output stream and the standard error stream. And they are not meant for the same purpose. They serve very different purposes. Although on the terminal, you cannot distinguish between them, right? Just visually, you cannot distinguish between whether you're sending an output to the standard output or standard error. But you as a developer, you need to know where you're sending the output to, because it affects how other tools are able to interact with your own tool. And there are certain conventions you should know. So for example, normal output should be sent to the standard out. right? And this is how you can do that. You just print. When you print using this format.print or forms.println, it sends data to the standard output. And it's just meant for your regular output. It's meant for either for feedback or for troubleshooting. So they are not meant for the standard output. The main application data is what is meant for the standard output, while everything else is meant for the standard error. So let's talk a little bit about why having debug statements is important for command line tools. Because unlike regular servers where if you have a problem, you can just attach your debugger and start stepping through the code. With command line tools, you don't have that luxury because people are running it on their own computers and you don't know whatever special configuration somebody is doing that is going to cause different problems to occur. So you need to have debug statements in your code that users can activate selectively so that when something fails, they can send you those logs and you can see exactly what happened. So here's an example briefly. So this is a command line tool I wrote, and if you look at the beginning of the command, you see f2 debug equals true. And when this environmental variable or when this environment variable is set, we can see some debug statements. And this is just step-by-step information of what the code is actually doing. So if there was a problem and the user sent me the logs, I won't just see the final result. I'll see how my software got to that point, and then I'll be able to know what the problem is. So it's just a very helpful thing that I found that really helps because you don't even in normal software you need this. So it's also very important for command line tools as well. All right, so let's talk about how to make a good, how to take a CLI, how to make one that's actually great, right? Because there are some unwritten rules about the terminal that you won't know until you start building command line tools. But let's talk about each of them now. So first one is your command line tool should be discoverable and self-documented. And what this means is that you just need to have logical names, right? When you're naming your flags and arguments, they need to be named logically. But the most important thing actually is the help flag. You need a very detailed help flag that shows how to use your software so that people don't have to Google how to do basic stuff. They need to be able to see all those things in the help flag. And an example of this is the git command. Everybody knows git. Git is actually a very good, it's very confusing in some ways, but it has some good patterns as well. And if you type git without any arguments, it's not going to do anything useful. But instead of just printing an error, it actually shows you a short help of how you can use it. So you can basically try to figure out what you want to do. And you can see some of the most common commands and then, basically find more help if you need it. So that's a very helpful pattern. Another thing that makes a CLI tool very good is being composable and scriptable, right? So as I mentioned, you need to be aware of the standard out and the standard error so that your commands can be changed. And then you also need to offer machine readable output. So I'm going to show an example of that. So this is an example where I'm passing some files to my command. I'm able to type this, right? I'm able to pass information from one command to another simply because I follow these rules. And then we get some results. But this result is meant for human consumption. It's not meant for machine consumption because it's not stable, right? If you try to parse this output, it's going to be tricky because it depends on the width of the table, for example, depends on how long the file name is. So that's where you need, say, something stable like JSON. And this is just another example of passing, bringing command line tools together to achieve a result. So you have the first command passes to the second one, and the second one, which is outputting JSON, right? And then the JSON, though, it outputs JSON, but JSON is on a single line, so you cannot read it easily. And then I pass it to JQ, and JQ is what beautifies it like this. So another thing is you need to provide clear and actionable feedback. So you need to make sure that your command always provides feedback. If it's especially for long-running tasks, an example here is the DD command. This is a Linux tool, but it doesn't provide feedback. So it's actually a bad example. I just want to show you what not to do actually. So if you are doing something, it just hangs like this, and then you can wait forever, and it's not going to indicate whether it's near completion or if it's hanging or if there's a problem along the way. So that's something that you should not do. And let's go to the next one. So it should be fast and responsive. So that goes without saying. You know, basically well defined. And and then also supporting flexible configuration. So an example of this, the best way for me to explain this is showing an example. So this is the configuration file that I defined for one of my command line tools. And if you look down here, there's a default value for the duration, which is 50 minutes. And when you run the software, it starts, I mean, if you just like focus, it, it defaults to 50 minutes, right? Which is in the configuration file. But if you provide an argument to override that, so you need to make sure that you can provide defaults and then still have the ability to override it as needed. And yeah, you need to use exit code correctly. So basically, 0 is success and 1 is failure. And there are other exit codes, but these are the ones you need to know about. And also, you need to be tolerant of user input. A good example of this is also Git, where if you make a mistake, it's going to provide a helpful command, helpful error that tells you what the most similar command is, so you can fix it. And this is an example of what not to do. Actually, if you type 50 without passing a unit, it fails, but it shouldn't, right? Because you can easily set a default where if there's no unit, it defaults to minutes, right? But you can see when you type M after 50, it works. So this is just some patterns you need to bear in mind. Now, this website has a lot of other tips that you can follow if you are building command line tools. It has a lot more than what I've been able to discuss here. All right, let's quickly talk about distributing your command line tool. So once you build a command line tool, you need to distribute it. And there's a lot of tasks you need to do. You need to build and compile for all the major operating systems. You need to embed the version info so that users can know what version they're using. You need to offer multiple installation instructions and so on and so forth. But one of the best tools that is available that you can actually use to automate everything I've just mentioned can be automated. You don't actually need to do it yourself. And you can use this tool called Go Releaser. I don't know if anybody has heard of this tool here. It's a very powerful tool that you can use to automate everything I've just mentioned. And essentially, you're going to run it through GitHub Actions. And when you run it through GitHub Actions or any CI platform that you are used to, and finally, it's not just about distributing software, it's also about documentation. You need to document your command line tool or really any software. But in command line tools in general, command line tools specifically, since they don't have a user interface, documentation is even more important. This is just an example of this. So this is the README for one of my projects, and it just has the brief information, how to install it, and some links to the documentation. And then in the documentation, you can see it's pretty much like a book, right? It has so many things, so many pages, really, right? So this is just an example of how to document your stuff in a proper way, especially for command line tools. All right, so that's it from me for this talk. I hope you gained something from it. Thank you so much.